The brake systems in Chrysler Corporation vehicles are engineered to provide more than enough braking for safe, secure stops. But sometimes customers feel that brake operation is not what it should be. And then we're faced with a problem that may be difficult to correct or explain.
When I step on the pedal, it doesn't feel firm like in my other car. It's soft and spongy, and the pedal goes to the floor while I'm waiting for a light. And sometimes the brakes feel rough on quick stops.
Okay, we'll check out the spongy brake and brake roughness complaints. We'll also cover 3 other problems: brake drag, front brake pull, and rear brake lockup. But before you start in on any brake problem, remember, servicing by parts replacement is no substitute for good diagnosis. Complaints about soft brakes began a while back when disc brakes and pedal linkage improvements were introduced. You'll find that some customers are simply not familiar with the increased pedal stroke and light pedal feel. You see, for easier pedal action under severe braking conditions, most Chrysler Corporation passenger cars now have a 4-to-1 pedal ratio. The pedal moves 4 inches to move the master cylinder piston 1 inch. On earlier models, the brake pedal moved 3 or 3.5 inches for every inch of master cylinder piston travel. So the current pedal linkage system does have a different feel. Now, the bottoming out feel, which some customers experience when they're at a full stop, is actually the result of normal booster runout. For example, let's say a booster reaches its runout point or its maximum assist point at an hydraulic pressure of about 900 pounds per square inch. Beyond booster runout, pedal operation feels so firm that the driver thinks it is bottomed out. The driver can still move the pedal farther and produce more hydraulic braking pressure, but it's all manual action from then on. You can demonstrate this effect by shutting off the engine and pressing the pedal several times to exhaust the booster vacuum reserve. Basically, spongy brakes are caused by air trapped in the hydraulic system as a result of incomplete bleeding or air ingestion due to low fluid level. When the pedal is pressed, the air compresses and the pedal feels soft. This compression also results in excess pedal travel. To remove air trapped in the system, use the recommended bleeding procedure given in your service manual. Be sure to bleed the system thoroughly, since air may be trapped several feet away from the bleeder screws. You may need to remove a lot of fluid to remove all the air. Excessive pedal travel caused by a bad master cylinder or a hydraulic leak can be diagnosed by a pedal fall-away symptom. Customers may incorrectly call this complaint a spongy pedal. You can check master cylinder operation from the driver's seat. First, make sure both reservoirs are full and then replace the cover. Turn the ignition switch to the start position to check out the warning light. Now, release the switch and apply light, steady pressure on the brake pedal, gradually increasing the pedal effort. If the brake warning light comes on and stays on after you release the pedal, the master cylinder is bad. Once again, if the brake warning light comes on and stays on after you release the pedal, the master cylinder is bad. Another cause of spongy brake feel is the incomplete bedding of the brake shoe linings. This low mileage condition usually clears up as the linings wear in and make full contact with the drum surface. Other problems, such as varying pedal travel due to loose wheel bearings and improper pedal return caused by improperly assembled linkage, are covered in your reference book. Now, Let's check on brake roughness. First, if roughness or vibration shows up when brakes are not applied, check front suspension alignment and tire balance. If these check out okay, then inspect front and rear tires and wheels for both radial and lateral runout. If the roughness shows up only when the brakes are applied, first determine whether it's caused by the front or rear brakes. Release the service brake. Hold the parking brake release out and gently apply the parking brake at low speed. Don't put too much pressure on the pedal. As the car slows, you might get a slight surging motion, which is normal and should not be mistaken for brake roughness. If there's no sign of roughness with the parking brake pedal applied, you know the problem is in the front brakes. To isolate the cause, check both front calipers first for seized pistons. This condition can produce hard spots, which can cause irregular friction and roughness. Seized pistons may also cause premature lining wear and brake dragging. In any case, do not blame rough braking on rotor scoring. Scoring alone cannot cause roughness. Also, inspect both rotors for lateral runout and thickness variations. Dimensions must be within specified tolerances for smooth braking. Incidentally, if a customer complains about front brake squeal, especially during light pedal applications, the cause is usually vibration of bonded lining type shoes. On compact and intermediate models, installing riveted lining shoes will solve the problem in most cases. Brake squeal seldom occurs in full-size models. If the parking brake test shows that the rear brakes are the source of roughness, check the drums for hard spot irregularities or excessive runout. Recondition drums if necessary, being careful to stay within proper specification limits. While you're at it, inspect linings for excess wear, which could indicate brake drag due to improper parking brake adjustment or seized cables. Where the customer complains about chirping noise during light pedal application, the shoe tabs may be squeaking. To remedy this problem, lubricate the 6 shoe tab contact areas on both brake support plates. As a further aid, relocate the drum 2 studs away from the original position to reduce shoe movement caused by out-of-roundness. Now, let's cover some additional problems you may encounter. Brake drag, front brake pull, and premature rear brake lockup. For brake drag, if all the brakes seem to drag, trapped hydraulic fluid may be preventing the brakes from releasing. Fluid is trapped due to the pedal not fully returning because of a misadjusted stoplight switch or incorrectly assembled linkage. For front brake pull, if the car pulls or drifts when the brakes are not applied, chances are the cause is poor suspension alignment, steering linkage problems, or radial tire pull. If the car pulls to either side as you apply the brakes, the linings may be contaminated by brake fluid or lubricant, causing them to grab or slip. Here you may also find a seized piston in one or both of the front calipers, which could cause a drift to either side, and a strong pull to one side when you step on the brakes. Now let's look at the causes of premature rear brake lockup. Brake locking or grabbing in low deceleration stops can result from several conditions which may also cause brake drag. You may find the parking brake adjusted too tight, out of round or spotted drums, or contaminated brake linings. Rear brake lockup can also result from front brake malfunction. This forces the rear brakes to do most of the stopping, something they are not designed to handle. If both rear wheels lock under hard braking, the proportioning valve may be faulty. Check your service manual for proper test procedures. Replace the unit if necessary. Remember that thorough understanding of brake system operation will help you pinpoint trouble causes more quickly. You can save valuable time and eliminate unnecessary parts replacement. Solving brake problems the first time will build your reputation for good work and customer satisfaction. fail-safe valve also provides a fast lockup release during a kickdown. The new lockup valve body is easily identified by the added module and by the new oil line. In the unlocked mode, oil is circulated through a new oil passage drilled in the transmission input shaft, around the unlocked piston face, back through the converter, and out between the reaction shaft and the input shaft. When the conditions are right for lockup, the switch valve vents the pressure on the front side of the piston, which causes the line pressure behind the piston to force it into lock. The lockup clutch friction material provides a pressure seal across its face to keep the converter in the locked up mode, and two seals on the turbine hub seal it at the center. You'll have to take the car on the road to see if the lockup clutch is actually locking up and whether it is holding or slipping. Hook up a good engine tachometer and read the engine speed in direct drive. When you're above 50 miles per hour, watch the tachometer as you press the accelerator to detent position short of kickdown. The tachometer should indicate little or no increase in RPM in the lockup condition. Some units, however, may show a slight increase in RPM during acceleration in direct gear. If the increase is not more than 250 RPM, the converter may be considered normal. Just as with any other torque converter, you can use the familiar stall test to check the converter stator clutch operation, which controls the torque multiplication. The stall test applies full engine power against an unmoving or stalled turbine, stator, and transmission, and is done in the drive range only. With a properly working torque converter, engine speed at wide open throttle will fall within the stall test specifications shown in the service manual. The manual will give you the correct stall speed for every engine torque converter combination. For the 400 V8, for example, correct stall RPM is between 1,850 and 2,150 RPM. Variations in engine RPM above this specification indicate transmission rear clutch slippage. Lower stall speeds, with a properly tuned engine, of course, would indicate that the stator clutch is not holding. Be sure to follow your service manual directions for just how to do the stall test. The test can be dangerous to perform as well as damaging to the transmission. There is very little more required in the way of service with a lockup converter. Flushing is not recommended, and for that reason the lockup converter does not have a drain plug. Also, the ring gear or balance weights must not be replaced, since the re-welding operation could easily damage the lockup friction material inside the converter. Can you use a lockup torque converter with any other transmission? Emphatically no. Even though the overall dimensions are about the same, there is no way to use the new lockup converter or lockup valve body with any other transmission. And lockup components specified for one engine may not be suitable for use in another car engine application, even if it too is a lockup. For that reason, be sure to observe the identifying marks on the lockup converter and follow the service manual specifications exactly regarding replacements. The lockup torque converter is a notable Chrysler engineering advancement in torque converter design, providing greater efficiency, better fuel economy, less engine speed, and lower transmission operating temperatures at highway speeds.